The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Odd Digit Numbers. Example, 55225, that is 55,225. In the previous two examples, we dealt with even digit numbers for finding out the square root. In the current problem, let us take a 5-digit number 55,225 and find out the square root. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, one group is 25 and the other group is 52 and the another group is 5. For the purpose of calculation, we can consider the groups in order as 5, 52 and 25. Let us set the number 55,225 by leaving 3 columns in the right extreme of the abacus. That is, the lowest 5 of the number should be set in the thousands column, 2 in the 10,000s column, and the remaining numbers in the subsequent columns to the left. Take the first group 5 and consider the perfect squares there. 4 is the only perfect square in 5. Take the square root of 4, which is 2. Set 2 by skipping a column to the left of 5 as 2 is less than 5. Now, 2 multiplied by 2 is 4. That should be subtracted from 5, which gives the remainder value as 15,225. In this process, we did not go for an assumed quotient. We mentioned repeatedly that when the divided value is a smaller number, say 1 or 2 or 3, we can simply take it as it is. In the case of the divided number becoming 7, 8 or 9, it is always safe to go for an assumed quotient by reducing 1 from the divided value. In this case, we straight away took the divided value 2 as the quotient instead of going for an assumed quotient. In the next stage, double the number 2 and set 4 in the extreme left of the abacus. Now consider 15 of 152 and ask how many 4s in 15. You get your answer as 3. In the case of small numbers, you need not have an assumed quotient. Therefore, straight away set the number 3 to the right of the first digit of the square root 2 and to the right of the number 4, which is set in the extreme left of the abacus. Now multiply 3 with 43, that is 3 multiplied by 4, which is 12, that should be subtracted from 15, which gives the remaining value of the first 2 digits as 32. Now 3 and 3, which is 9, should be subtracted from 32. That gives the value 23 as the remainder. Altogether, we are left with the remainder 2325. Look at the square root now. In this problem, you are going for a third digit in the square root. In every stage of division process, we have to double the square root before going for subsequent calculations. In the square root section, we have 23. That should be doubled, and therefore the 43, which is set in the left extreme of the abacus, becomes 46. Now consider 46 and 2325. look at the first digit of the dividend and the divisor. As 4 is larger than 2, take the first two digits 23, ask how many 4s in 23 by saying 5, set the 5 to the right of the square root 23 and also to the right of 46. Now multiply 5 with 465 and subtract that from 2325. That is 5 multiplied with 4, which gives 20. That should be subtracted from 23, and the remainder at this stage is 325. Now multiply 5 with 6, which is 30, and therefore subtract 30 from 32 of the dividend, and at this stage we are left with 25. Now multiply 5 with 5, which gives 25. That should be subtracted from 25. In this problem, there is no remainder, and therefore the square root is 235.